Section 2.3, example 3 is solving an application using a formula. It takes Andrew 30 minutes to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer, and he drives an average, or he averages 10 miles an hour less in the morning than in the morning. How far does Andrew drive to work? So first off, I don't know exactly where to start because we don't really have an equation or anything to compare it to. So let's try to look for some of the unit conversion. So it takes Andrew 30 minutes. So we have time, some conversion of time to drive to work in the morning. He drives home using the same route, but it takes 10 minutes longer. So we still have that time aspect. And he averages 10 miles per hour. So there we go. So 10 miles per hour less than in the morning. How far does Andrew live? So what we have is a rate or a time, a rate, which is our miles per hour, and a distance. So if you do recall, maybe you've heard it before, but we know that distance is our rate times our time. So we could think of this like distance is equal to rate times time. So we have our miles per hour, like a rate, that's what they're giving us here. So miles per hour, we can multiply that by some sort of hour time here. And here our distance is going to end up being in miles. You could clearly see the hours divide out. So it looks like this here is going to be our sort of equation. So distance is equal to rate times time. So we could throw all of this into a table to make it a little bit easier for us to see. And hopefully that helps. So it looks like there's two parts of the equation. So our to work part and our from work part. So he drives home. So from home to work, work to home. So our two parts, I'm going to call them so to work and from work. And from there, we have a couple of parts to this equation. We have our distance, our rate, and our time. So distance, rate, and time. So distance, we need to kind of identify that as being in miles. Rate, miles per hour, and time is going to be in hours. So distance is going to be in miles. Rate is going to be miles per hour. And time is going to be in hours. All right, let's start with the first part. So it takes Andrew 30 minutes to drive to work. 30 minutes. But we need that to be in hours. So 30 minutes. Actually, erase that part because we shouldn't have the 30 minutes. Let's convert minutes to hours. So we need a equivalence between minutes and hours, so that way we could turn these 30 minutes into hours. So 30 minutes, I know that there are 60 minutes in 1 hour. And we could set up this conversion, and we just have to make sure that everything is set up properly. So let's try 60 minutes per 1 hour. No, it doesn't look like anything simplifies here. So let's flip it upside down. 60 minutes per 1 hour. And now at this point, our minutes divide out. And we could just multiply across. So 30 minutes times 1 hour. 30 hours divided by, we have 1 times 60. And so we have 30 divided by 60 is 0 0.0 or 0 0.5. So 0 0.5 hours. And that's what we could put in for this first part for time. So time to work. So 0 0.5 hours. All right, so that's that first part. Takes 30 minutes to drive to work in the morning. He drives home using the same route. So here we have our distance is the same for both parts, but it takes him 10 minutes longer. So let's set that part up. So we have 30 minutes plus 10 minutes is equal to 40 minutes. And we could change this to hours doing the exact same thing. So we could say 40 minutes, we multiply by our conversion, 1 hour is equal to 60 minutes. Our minutes divide out, and we're left with 40 hours divided by 60. And it doesn't seem like this is going to be a nice, nope. So we could leave this in fraction form by just reducing it. So divide both top and bottom by 10, we end up with 4 hours divided by 6. And divide both top and bottom by 2. That's going to be 2 over 3. 2 over 3 hours. Now we have that part. And let's finish reading. So it takes under 30 minutes to drive to work. That's that. In the morning, he drives home using the same route. So that's these two. But it takes him 10 minutes longer. Got that time. And he averages 10 minutes an hour less in the morning. So 10 miles an hour, we don't have to convert anything. But here it looks like they're saying that this is our rate. And this is our rate. 10 hours less. So rate minus 10. And now from here, don't think we need this for a minute. Okay, so now from here, we could set up our equations. So our equation for this first part, we have distance is equal to our rate times time. So distance is equal to our rate times time. So D is equal to R times, actually we could see exactly what this is. So you could see, and this is going to be in miles. So setting these up, we have our rate in miles per hour, that's our unit, times 0.5 hours. The hours divide out, and we're left with 0.5. We're left with 0.5 miles, or our rate times 0.5 miles, which makes sense because distance is already in miles. So we could just leave our equation as rate times 0.5. And same thing for the second one, our distance is equal to, here when we multiply these two, hours divide out, and we're just left with that part. So 2 over 3, or we could do 2 over 3 r minus 10. So 2 over 3 r minus 2 over 3 times 10. You could just imagine that that 10 is over 1 and you can multiply across, leaving us with 20 over 3. Minus 20 over 3. And there we go. So now from here, the last part they're asking for is how far does Andrew drive to work? Here we are set up where our distances are exactly the same. So we could set these two equal to each other. So that way we could solve for R. So we could solve for the rate. And I know we're not looking for rate, but we could easily plug it back into one of these two equations to get the distance, which is what we are looking for. So let's set those two equal to each other. So R times 0.5 is equal to 2 over 3r minus 20 over 3. I'm so glad we went over that other section because we know how to solve these. Even though it looks really intimidating with the fractions and the decimals, I think we could still do this without having to worry about it too much. So here we're going to look for our LCD. So something that's divisible by 3. So I'm just going to multiply both sides by 3 to get rid of those fractions. So 0.5 times 3, that gives us 1.5. 1.5r is equal to, when we multiply the 3 over here, it divides out. So we're left with 2r. When we multiply the 3 over here, that divides out. So we're left with a negative 20. And from here, we could start solving. We can move all of the variables over to the left side, leaving us with our right side. So minus 2r on both sides. 1.5 minus 2 gives us a negative 0.5r. And that's equal to a negative 20. So now whatever you're more comfortable, you could see this as half and multiply it by 2, or multiply by a negative 2 to get rid of the negative and the decimal. Or if that confuses you, you could just divide both sides by negative 0.5 to get r by itself. At this point in your math career, I think you've developed a math style. So whatever makes more sense to you, you could definitely use that. But from here, negative 0.5 divides out with negative 0.5. Negative divides out with negative. And here we have r is equal to 40. Again, we're not looking for the rate. They want to know how far Andrew drives to work. So we could plug it into either one of these equations, because now we have r, we could find our distance here, or we could find the distance here. Just because I'm a little bit lazy, I'm going to plug it into this one, because over here we would have to multiply that fraction, figure out that fraction, subtract a fraction. I'm going to go with the easy route and just plug it into that equation. D is equal to r times 0.5. R we found out was 40. So 40 times 0.5. D is equal to 20. And over here, remember we said miles. D is in terms of miles. So our sentence that we want to end with is, it takes, or not it takes, Andrew drives 20 miles to work. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.